Ladies and gentlemen, good afternoon. For over a year now, we've been working on something we believe is fundamental, something important, both on the global and personal scale, your digital security. Right now, as you're sitting here, there's a very high chance the company you work for, the bank holding your savings, or your personal accounts are being hacked or even targeted by hackers. If you take a look at this map behind me right now, this is a global live. Hackers are in action. Every single second, attacks are being conducted of various types. In only one day, an average of 2,500 attacks take place. The collective losses of this, $10 trillion. This is no small number. This accounts to around 10% of global GDP. This is huge. How do we protect ourselves? We need cybersecurity experts. However, the job of defending ourselves is a pretty hard one. Cybersecurity professionals need a large amount of information across several different domains to be able to be experts. Now, this has created a major barrier. And it has proved to create a world that is 3.4 million professionals deficient. However, the real challenge is that there's no practical experience. Hackers can hack anything at any time. Cybersecurity professionals, on the other hand, they need to find the proper and adequate experience. They struggle to find practical experience. This calls for a change in mindset, a change of plans. And to do that, we have to think ahead. Instead of just defending ourselves and taking the necessary precautions, why don't we immerse ourselves in the battlefield? Why don't we play the attacking game? If we can think the same way an attacker thinks, if we have their mindset, I'm pretty sure we can defend against them. But how? How can we win a game against a threat that's invisible? Where is it coming from? What is it targeting? And when is it going to come? To do that, let's think about something. Let's take an analogy. A game where strategy and foresight are supreme. Chess. In chess, every single move matters. The more you play, the more strategies you know. And as a result, you can anticipate the game's flow and counter your opponent's moves. As a result, you can build a solid defense. If you have that mindset, if you can think like an attacker, you can do what's most important. Protect your king. Wait a second. What about someone who hasn't played the game? Hasn't seen the strategies? Cannot think like an attacker? What happens? Checkmate. You lose. And losing in cybersecurity has grave consequences. You lose your money, your personal accounts, and what's most scary, your privacy. The only way to get better is to play more. You need to be on the playground, which is where this team came into place. We created a cyber range, a playground for cybersecurity professionals. We offer them the practical experience they need. And we do that by simulating the real world. But what does it mean to build a cyber range? What does it mean to simulate a real-world threat?
Now, let me introduce to you the concept of labs. A lab is a controlled environment. You can simulate some actions that impact only this environment. To make things easier, think of a flight simulator for pilots. It's a controlled environment where they can practice flying their aircrafts without putting real passengers or their flights at risk. By this, they can develop their skills without any harm. So in our context, a lab is a controlled environment created for cybersecurity individuals to build their hacking skills. And the better they become at hacking, the better they become in defending against it. Now, in order to complete this lab, there has to be some sort of a solving mechanism, a checkpoint that the student reach, and then they're informed that the lab is solved. Seems a bit complicated, right? Actually, yes, it is. And the complexity resides in two main issues. The amount of advanced technical interdomain knowledge required to build a lab is huge. An individual who wants to create their own lab is not only expected to have basic knowledge in cybersecurity, but also application development, computer networks, and advanced configuration skills. Now, even if someone acquires knowledge in all those domains, how much time would they need to build a single lab? On average, it may take up to 12 hours to create a single lab. But why is it that complex? Let me take you through the whole process of creating a lab from the beginning to the end. You start by a lab idea. After the lab idea, you create a design schema for the components that will be included in your lab. You will then proceed with application development for each component of those. Set up your network to connect each component together. Then you'll need to set up the required servers for your lab. And finally, write some configuration files for each and every single machine in your lab. And that's not it. Then we move on to the final phase, testing phase. If any error happens, you will have to start all over again. So how can we overcome this problem? Behind me is a sample of a complex lab structure that we once wanted to create. We want to overcome this problem. We want a process which is fast, smart, and simple, where between the lab idea and the output lab, not a dozen of steps. And by fast, smart, and simple, I mean only one thing. And you all know what it is: AI. This innovative technology that changed all our lives, can it be used in that case?
It actually can. Here's why we use generative AI to be specific. First of all, given enough power, it is able to simplify the task at hand by making it end-to-end and more abstract. This means that the user does not need to explain any of the technical requirements in his input. It's just a simple description in English. So, more significantly, it's able to automate the conversion of the input description to the final lab environment. So with that in mind, we tried using the state-of-the-art large language model behind ChatGPT. We would give it the abstract description of the cybersecurity use case or the required lab environment and wait for it to generate. Unfortunately, it's not that simple. First of all, the output is just text, which means we need a separate process that extracts the code of each file making up the environment. Then we try running that environment, and it might turn out to contain errors. This is an inherent problem in this approach, because that same LLM could have been able to solve that error potentially if it was given the chance. But it's like we're forcing it to get it exactly right from the first time. Finally, as the complexity of a scenario grows, so does the number of files and the required steps. This can overwhelm the context of that LLM because it needs to maintain awareness of multiple interconnected components and the relationships. So what features should our generative system have to reliably create usable lab environments? First of all, it needs to create a high-level execution plan. Then based on that plan, it needs to think about what needs to be done and take the corresponding actions, such as writing to a file or executing a terminal command, for example. Once it has created all necessary files, it needs to execute that environment, test it, observe any errors, and take corrective actions to solve these problems. This introduces the concept of an LLM-based agent, which has all the properties we've just described. The agent is intentionally designed to be analogous to a human. The LLM is its brain, which provides it with reasoning and decision-making capabilities. It has a mechanism that allows that brain to plan by breaking down complex steps into manageable tasks. It's also able to remember and maintain awareness so that it can take future actions based on steps it has already done. And finally, it is provided with external tools that allow it to execute the environments it has already created, and then take the corrective actions. Unfortunately, this agent is still not able to create scenarios of the complexity we desire. First of all, subtle errors can propagate through the chain and accumulate until it's too difficult to solve. It can also get overwhelmed because at the end of the day, it still has one LLM. So it can still get overwhelmed because it needs to maintain awareness of the files it has created, the steps it has already taken, and all the tools it has access to and when to use them. Finally, although it can remember the previous steps it has taken, it finds it difficult to dynamically change its approach and explore alternative solutions when the current path isn't working.
Now, even with the human-like thought process of an agent, the task of creating a scenario is still far too complex for it. But let's take a step back into the real world. What do we as humans do when we face a challenge that is too difficult for a single person to perform? We collaborate, work together as a team, as a workforce, that is managed and assigned roles and responsibilities, such that each person does a chunk of the work, and it's all of it being put together to achieve something bigger. Now, how can we apply this to our system? Where we'd have specific roles for responsibility assignment, the designing a plan and the requirements and specifications for the creation of the lab scenario, to actually implementing the code and configuring each component of this scenario. To also the testing and validating of the scenario. But not just that, where there would also be the communication of feedback across all of those roles to achieve the ability to trace back mistakes and be able to iterate on any of the previous steps. And this is why we decided to implement our own state-of-the-art multi-agent system that is capable of breaking down the complex task of creating a scenario into a series of simple tasks that each can be done by its own specialized agent. At the core of our architecture, there's the master agent, who acts as the manager, overseeing all operations and ensuring the environment is done successfully. The master agent receives the user's description of this lab and creates a detailed implementation schema that will be used for the rest of the generation process. This schema includes details for every single machine, from requirements to specifications to be followed as a template for the implementation process. Now, for each machine described, the master agent then calls a machine worker agent, which is responsible for implementing all the code and configurations for that single machine. Now, after all machines are created, the master agent then calls the QA agent, who is responsible for inspecting the files, making sure that the environment is functional and actually has the desired vulnerability in place and is solvable by the end user. The environment is considered complete if and only if the QA agent gives the final approval. But to actually have an environment at the output, we equipped our agents with tools, giving them the ability to write files, access the terminal to run and test the generated code, and even be able to keep track and recall important contextual information throughout the generation process through the shared memory vault. And also be able to assist itself with external up-to-date knowledge, an external up-to-date knowledge base of documentation and sample code that is scraped from the public web. With this, we have achieved a system that is capable of generating networks of containers environments for our environment labs.
Let's just pause and take a step back and appreciate the significance of this masterpiece behind me. Because this is not some ordinary innovation. No, for so long now, cyber ranges have been highly limited by the complexity of their lab creation mechanisms. Let's say you want to create a lab. You need a team of experts with strong inter-domain knowledge to come up with a lab idea, design a schema, build the application, set up the network, set up the servers, and so on and so forth, and so many immediate steps, such as configurations. It just takes too much time and manual effort. We've abstracted this entire process and turned complexity into simplicity. We've abstracted this entire process and turned complexity into simplicity. Now, what used to take hours and even days worth of work is now just done within a matter of minutes. And no, let me bring your attention to something. This is not some AI workflow improvement tool. No, this is a new paradigm shift in the way labs are designed from the ground up. Our goal was to simplify and abstract the lab creation process. And with the introduction of the multi-agent system, we now can do that within a matter of minutes. Each agent is specialized for a specific task, and they all run asynchronously. Now, with the multi-agent in place, what good is innovation if we don't use it? This is where we had to make a decision. This is where theory meets practice, where innovation gets bridged with application. And that's why we decided to take it a step further and introduce a fully fledged cyber range platform, a platform where users can train on and deploy realistic real-life scenarios. Now, again, we don't settle for less. This is not going to be some ordinary platform, just like any cyber range available on the market. Oh no, this is going to be a platform that's powered by the community. Think of a GitHub, but for cybersecurity, where users can actually share their scenarios that they created with other users all around the globe for them to train and try the different scenarios. We're introducing a library of full scenarios of common attacks, such as cross-site scripting, SQL injection, DDoS attacks, and so many more. And the star of the show, our capability to generate scenarios in AI within a matter of minutes. But it's not just enough to have a platform that manages the creation of these AI-generated scenarios. We need to manage the entire lab workflow from A to Z, from start to finish. That includes creation, deployment so that you and other users all around the globe can access them, introducing some sort of novel completion mechanism to indicate the end of a lab, and finally, why not, let's clean up the resources, because again, we want to be good for the environment. All of this has to be immersed in a simple and beautiful user experience that any beginner user can easily use. Now, such a complex platform requires only state-of-the-art tools and technologies. We used Weaviate for our vector search, WireGuard for secure remote access, and powering our mastermind agent system is a combination of LangChain and OpenAI. At the core of our development, the website, we use Next.js as our backend, Prisma as our ORM, Fast API to stitch everything together, and Docker for containerization. And finally, we had to build that beautiful user experience. So we used a combination of the state-of-the-art React MUI and JavaScript. This would not be a technical presentation without presenting some sort of architecture. So I'm going to make this quick. At the core, we have the platform backend, which is split up into two main modules. On one side, you have the user management. On the other side, you have scenario management. It's connected on both sides. One side is the front end, and the other side is our mastermind agent, which is triggered using a simple API call. We also have the deployment API to actually deploy these created scenarios. And finally, all this data has to be stored in synchronized databases between the user and the scenario. Let me take you through a simple example of what happens technically when a user wants to create a scenario based on AI. The flow is very simple. It starts in the front end where the user enters a high-level English prompt of the scenario they want to create. This then triggers the scenario creation module in the backend, which then triggers our API for our agent and gets our mastermind agent to work. This data is then stored in the databases for later access. And these scenarios are stored in directories that are separated by metadata. And to ensure scalability, in case we want to shift over from local deployment to S3 storage buckets in the future, the directories are actually stored in the databases by their actual path. And with that, we have successfully completed the creation of an AI scenario. But do we only stop there?
Definitely not. By now, we have successfully created the cybersecurity scenarios, but after all, they are just code or text files that are stored and static. They need someone to actually execute this code and run it to build the infrastructure from ground up to create the cybersecurity scenario for you in instance or in less than minutes. So let us take you through the deployment and accessing part of our architecture. With a simple click of a button on our easy-to-use interface, you click on Start Scenario, which activates the Scenario Deployment module. This Scenario Deployment module then fetches these code files from the relevant databases, fetches the actual files, runs some commands to execute them and build for you the infrastructure and the servers, and then give you dedicated remote access that is very secure and is only created for you by building a network specifically for you using our state-of-the-art VPN architecture using WireGuard. And also, you are now able to access it. By this, the scenario is now deployed, and you can access it from anywhere in the world. But how can you actually prove that you are a real hacker, that you were able to learn the cybersecurity accomplishment and goal, and that you successfully learned the lesson. Here comes the scenario completion part. You submit a simple thing to the front end. This thing is compared with the same thing stored in our scenario database. If it matches, then you have successfully solved the scenario, and we clean all the infrastructure that was built for you and killed the servers. If it does not match, then we keep track of your failed attempts and the number of times people try to actually solve this cybersecurity scenario in the scenario status component. But what is this thing that we mentioned many times? In the cybersecurity community and between hackers and hacking competitions, there exists the concept of a flag submission. What is a flag? A flag is a hidden string, a hidden sentence that is put in a very secure place in the infrastructure created for cybersecurity hackers. So for example, if your goal is to hack into a system and reach the password of the administrator, this flag will be the password of the administrator. So when you reach the password of the root or administrator account, it will be something like CTF, this is the secret flag. This thing, when generating and when we generate the cybersecurity lab, is also stored in the database. So when you submit it, we check if they match or not. By this, we have successfully perfected the scenario in a creation workflow, starting from creation, deployment, accessing, completing, and cleaning of cybersecurity scenarios. We now have a fully functional and working cyber range that is able to compete with all the top of the world cyber ranges. But after all, this presentation has been very technical. The architecture was very complex. Let us see this masterpiece in work. Let us begin by the multi-agent system that we described a lot. Here, the users are accessing our new web interface, similar to ChatGPT, but a lot easier to use. You give it a very abstract description, 1 or 2 sentences, asking it here to create a website similar to Google search that is vulnerable to a famous web security attack called cross-site scripting of the reflected type. As you will see, we will submit this to our cyber range, and the multi-agents will start cooking and working together to build it. So here the planner agent starts working, creating files, communicating with the other worker and machine agents to build this complex infrastructure without taking much time. On the right-hand side is the actual very complex process that the agents have to go, executing commands, writing files, and saving them. And by this simple, the cybersecurity scenario was actually created. A very complex directory structure, as you can see, and the user decides to share this with the rest of the community. So he gives it a name, a description, sees a figure visualizing how the actual lab looks like, gives some extra metadata, and then clicks on the create scenario to publish this to the rest of the world. And as simple as that, the complex process of creating a cybersecurity scenario was created. But now, let us see how real hackers, how real cybersecurity students actually utilize this newly created lab. So on our hacker-themed website, our colleague Ali is creating a new account for himself, putting in his email and password, of course, that is stored very securely in our database. After all, it's a cybersecurity project. He's then signing in, and he's going to explore our wide list of cybersecurity scenarios that are handpicked. And he will see the newly created scenario that we just created in front of you, the simple reflected cross-site scripting. With the simple click of the button again, start challenge, he will see the instructions to access this remote network that was specifically dedicated for him. He will run the commands. And as simple as that, by running these commands, he should by now have access to this newly created web server for him. He's checking that he can actually access it. And now he will open the actual website to see how it looks like. An actual search page, not very similar to the design of Google page, but is specifically vulnerable. Let the actual attacker try it, and it is vulnerable to reflected cross-site scripting. And here he was able to obtain the flag to prove his worthiness. Let him submit the flag, and he successfully solved it. And by this, we have created the perfect cybersecurity scenario.
Now, what Shizat show is one scenario. We conducted qualitative experiments with 14 different scenarios over different cybersecurity domains with different lab complexities, stretching the capabilities of our platform. By this, we can confirm that we were able to engineer a complex agent design, powered with the intended tools to generate the lab, and you utilized this innovative technology in building our platform. And that's why, ladies and gentlemen, we were chosen in a research program for innovative AI solutions around the world, funded by OpenAI. The leading AI tech company funded us with £200,000 worth of credits on their platform, as well as research assistance. In complete to this research, we evaluated those 14 scenarios based on two perspectives. Accuracy, which measures how much the generated lab matches the input description by the user. And functionality, which tests whether this lab is actually working correctly or not. For accuracy, we used two metrics. Component inclusion, which measures if all the components have been included in the lab, and configuration correctness, which measures whether those components were actually configured correctly. For the functionality, we used three metrics. Error-free, which indicates that the lab was successfully deployed. Behavioral consistency, which indicates that the lab simulates the intended behavior described by the user. And solvability, which tests whether the injected flag is reachable by the user. We measured those 5 metrics based on a 3-point scale, based on how much they met the requirements. And we are proud to announce that our solution, the current state of the art, achieved a 100% component inclusion rate. It achieved 72% configuration correctness, 75% of the labs were error-free and deployed without any errors. And only 68% of them simulated the intended behavior. And finally, 72% of them were solvable. By this, we completed our research, and we're aiming to submit it to those conferences. We're also aiming to publish our experiments to be used as a benchmark for other researchers in the domain, completing our first empowerment outcome for this project.
Okay. By now, all of you probably think, okay, what is this group of 6 technical nerds that just only focus on the technical side? But I'm here to prove that wrong. No, we didn't only focus on the product side, on the technical side. We also focused on the product. So much great research goes to waste because people don't actually know how to take it to market. But we decided that this was not going to be the case. So let's take a look at our immediate market, which is the Middle East and Africa market. The total addressable market, which is the cybersecurity market, is valued at over $13 billion in the region. Of that market, approximately 2 to 3% is only the cybersecurity training market, which we call the serviceable addressable market. That's valued at over $400 million US. And we aim to capture just a piece of that market. But what is this value that we're going after? To save some time, we did some calculations and approximately narrowed it down to we're going to be targeting 16 universities in the industry, in the region, as well as 44,000 enterprises. And that leaves us with a serviceable, obtainable market of approximately $44 million. Our target market is going to be enterprises, cybersecurity individuals, as well as instructors who aim to use this platform to train students in their classroom. And this is going to be some sort of subscription-based model where we're going to be offering different tiers and different levels of packages that people can subscribe to. Our immediate costs, aside from development, are going to be the AWS hosting fees, as well as the OpenAI fees. And I think at this point, it's safe to say that we've transformed what's possible in cybersecurity education. We've pushed the boundaries, and we've changed the game. We took what all of our competitors do and did it even better. Cyberbit, they're too static. TryHackMe, they're too outdated. Hack the Box, they don't have AI. So this is what we like to call a new business model, an environment as a service that's powered by the community and supercharged by AI. So I'd like to welcome all of you to a new world where cybersecurity training is only a prompt away. Thank you.